Dear students, today we are going to discuss about hybrid parameters and inverse hybrid parameters. Hybrid parameters are represented by H parameters. Inverse hybrid parameters are represented by G parameters. Let us see. H parameters are used in the case of transistor circuits. In the case of hybrid parameter, the hybrid matrices describe the two-port network. Here we will be representing the voltage of one port and the current of other port in terms of voltage and current of different ports. See here, in this case voltage of one port and current of the other port act as independent variables and they will be represented in terms of the voltage and current of the subsequent ports. See here we are having a two-port network V1, V2, input port voltage, output port voltage, I1, I2, input port current and output port current. Here we are representing V1 and I2 in terms of I1 and V2. So here the independent variable will be I1 and V2. Dependent variable will be V1 and I2. See here you can see the equation. V1 and I2 are represented in terms of V2 and I1. That means V1 and I2 are dependent variables and I1 and V2 are independent variables. So in this case ports are port 11 dash and other port is port 22 dash. So we will represent the V1 equal to, here we are representing in terms of hybrid parameters. So we are using H11, H12, H21 and H22. So V1 will be equal to H11 into I1 plus H12 into V2. So V1 is expressed in terms of the port current I1 and port voltage V2. Next I2 will be equal to H21 I1 plus H22 V2. So you should remember this equation. So the basic of every parameter will be the first equations. So you should remember the equations corresponding to H parameter, Y parameter and Z parameter, and when you got that equation then you can easily find out the different parameters. So now you have the basic equation corresponding to this two-port network. From this you can write the matrix equation. So first matrix is V1, I2, that is written here, and the second matrix is H11, H12, H21, H22 matrix, that is hybrid matrix. Next one is I1 and V2. Next matrix is this. So this is the matrix representation for this hybrid parameter. Next in this we have to find out different parameters H11, H12, H21 and H22. For that we are taking the same equation again, and here there are different variables. Suppose we are putting I1 equal to 0. What is the meaning of I1 equal to 0? That means this port is open. That is its meaning, right? Whenever I1 equal to 0, you can easily find out when this quantity equal to 0, this will become equal to 0, this also equal to 0. So once we are open circuiting the input terminals 1 and 1 dash, we will obtain the value of H12 and H22. So H12 equal to V1 by V2 at I1 equal to 0. Similarly, H22 equal to I2 by V2 at I1 equal to 0. Similarly, when we are taking V2 equal to 0, what is the meaning of V2 equal to 0? When V2 equal to 0 means that we are short circuiting these terminals 2, 2 dash. So V2 will be equal to 0. So when V2 equal to 0, this term will become 0 and this also becomes 0. So from the above first equation, H11 will equal to V1 by I1 and H21 equal to I2 by I1. So you can write the equation as H11 equal to V1 by I1 at V2 equal to 0. You can see that this is the ratio of voltage and current. So it will represent the impedance and it is obtained by short circuiting the 2, 2 dash terminal. So we can say it as a short circuit input impedance. So H11 can be represented as a, what is impedance? That is reciprocal of admittance, that is 1 by Y11. So H11 is the inverse of admittance. Okay. And next H21 is equal to I2 by I1. So what is this ratio? This is current ratio. That is, this will represent the forward current gain and it is obtained by short circuiting the 2, 2 dash terminal. So we can say it as short circuit forward current gain. And we will have, in the previous discussion, we have from the admittance parameter, we will get that H21 will be equal to I2 by I1. That I2 by I1 is same as Y21 by Y11. So there is a direct relationship between this hybrid parameter H21 with Y21 and Y11. Similarly, we will get the parameter H12, that is equal to V1 by V2, that is obtained by open circuiting the terminals 1, 1 dashes, that is I1 equal to 0. So this will represent the ratio of voltages, so it will give the voltage gain. So it is obtained by open circuiting the 1, 1 dash terminal. So we can say it as open circuit reverse voltage gain. See, in the previous discussions of impedance parameter, we have derived V1 by V2 equation, that is Z12 by Z22. So H12 is related to this Z12 and Z22 by this equation, that is H12 equal to Z12 by Z22. Similarly, H22 will be equal to I2 by V2, that is the ratio of current and voltages. It is obtained by open circuit in 1, 1 dash terminal. So it is open circuit admittance. So open circuit admittance, we have the equation, admittance will be the inverse of impedance, that is equal to 1 by Z22. So H22 is related to Z parameter as 1 by Z22. So here in the equation, it is also shown the different relationship of this hybrid parameter with Y parameter, hybrid parameter with the Z parameter, and hybrid parameter is related to other Z parameter and Y parameter by this equation. So this is the basic equation, and you can do problems by using this equation. Next, we can also go to the term, how we can draw the equivalent circuit corresponding to this. For that, we are going to this equation. See here, first V1, that is input port is V1, that is voltage is V1, and current will be I1. And in the current I1, you can see that this V1 indicates by this equation. That means this term will be voltage and this term also will be voltage. Here you can see that voltage is obtained by the product of impedance and current. So this H11 represents the input impedance. So you can first draw the first section, that is V1 is marked here, I1 is also marked, and H11 is the representing the impedance, that is represented by a rectangular box. And next term, you can see next term will be, since it is voltage, so this will also be voltage. So this can be represented by a voltage source, that is dependent voltage source. So H12 V2 represents the dependent voltage source. You can see here, that is H12 V2 that is represented by this dependent voltage source. And when we are going to the output section, that is I2 will be equal to this equation. So here you can see that each term will be I2, that is current. So this current represents a current source, that is a dependent current source, and this will represent the product of voltage and impedance. So that will be equal to product of voltage and this will be admittance, right? So V2 and H22, so we can represent H22 by the equation, by the representation rectangular boxes. So H22 can be, you can represent it like this. Here is H22, and here these terms are current. So you have there is a difference, that is current sources will be added, means they will be parallel. They can be represented by a parallel combination. In the previous case, here we are representing voltage sources by series combination. Since they are added, so they will be connected in series. In the case of current equation, the branches, these individual terms will be connected in parallel, then only we can add those currents. So this will be an impedance, this will be an admittance H22, and voltage will be V2, and this represents a dependent current source. So you can represent H22 as a rectangular box, and this will be a current source. Since it represents a current term, so this branches will be parallel. Since this side represents the voltage, so these branches will be series. So this is the equivalent representation for the hybrid parameter. Okay. Next, we can go to the topic inverse hybrid parameter. In this case, here in the previous case, we have represented the port 1 voltage and port 2 current. So in the inverse parameter, we will be go to port 1 current and port 2 voltage. So that is the difference. So here in this case, current at input port I1 and voltage at the output port V2 can be expressed in terms of I2 and V1. That is the difference here. So I1 will be represented by G11 V1 plus G12 I2, and V2 will be represented by G21 V1 plus G22 I2. So this is the equation. You should compare the previous hybrid parameter equation and this equation. So there is no need to by heart these equations. There is a relationship between these equations. So you should remember that relation, then you can easily write this equation. Okay. Here we will take the first port current and second port voltage. And so we will write the equation of current in terms of first port voltage and second port current. In the previous case, we write first equation as first port voltage in terms of first port current and second port voltage. Okay. So here I1 equal to G11 V1 plus G12 I2 and V2 equal to G21 V1 plus G22 I2. So from this equation you can write a matrix form as I1 V2 and this is G11, G12, G21 and G22. Next voltage V1 and I2. So this will be the matrix representation for this inverse hybrid parameter. The quotients in the above equations, that is G11, G12, G21 and G22 is called inverse hybrid parameter. Okay. So next our aim is to find out these inverse hybrid parameters. For that there have a relation, that is H11. We have in the previous discussion, that is hybrid parameter are H11, H12 and H21 and H22. So the inverse of this matrix, that is matrix inverse, will be equal to G11, G12, G21 and G22. This is proved relation. And we doesn't need the proof of this relation, so you should remember this. Okay. So the individual G parameter is obtained from the equation. Here we have this equation for finding different parameters G11, G12, G21 and G22. We have used the same theory, that is first of all we have to take V1 equal to 0. What is the meaning of V1 equal to 0? When V1 equal to 0, that means that input port is short circuited. Next we have to take I2 equal to 0. What is the meaning of I2 equal to 0? I2 equal to 0 means that output port is open circuited. Okay. So let us see, whenever we are letting I2 equal to 0 and V1 equal to 0, we will have a different relation. So when I2 equal to 0 means that this term becomes 0 and this also 0. So from the first equation, G11 will be equal to I1 by V1 and G21 equal to V2 by V1. Okay, that you have got, that I2 equal to 0, G11 equal to I1 by V1, G21 equal to V2 by V1. So here this is the ratio of current and voltage, so that will be the admittance, right, for the first port. And this will be the ratio of voltage to voltages, so it will be the voltage gain. So we can say it as open circuit voltage gain, and here we can say it as a open circuit admittance. So we know that open circuit admittance will be equal to 1 by Z11, that is the inverse of impedance. So G11 is related to 1 by Z11, okay, by G11 equal to 1 by Z11. Next, for getting the relation, we are using V1 equal to 0. What is the meaning of V1 equal to 0? V1 equal to 0 means that input port is short circuited. So this term will become 0 and this term will become 0. So I1 will be equal to G1 to I2 and V2 equal to G2 to I2. So we can write G12 equal to I1 by I2 and G22 will be equal to V2 by I2. So G12 equal to I1 by I2 and G22 equal to V2 by I2. So V2 by I2 means that here I1 by I2 means that it is a ratio of two currents. So it is a current gain, right? So since it is relating first port and second port, we are writing it as a reverse current gain. Here it is relating second and first port. So here we are taking it as an open circuit voltage, and here it is obtained by short circuiting. So we are taking it as short circuit reverse current gain. And next, here we are taking G22 equal to V2 by I2. So here V2 and I2 is the ratio. Ratio means that it is a voltage by current ratio, that is impedance. It is obtained by short circuiting the first port. So we are saying it as a short circuit output impedance. And here the impedance, we know that it is obtained by the inverse of admittance. So G22 will be related to admittance as G22 will be equal to 1 by Y22. So this is the inverse hybrid parameter. It is easy to write the equation and to find out different inverse hybrid parameters. So that's all about this topic, that is inverse hybrid parameter and hybrid parameter. Next we can do a problem that we will discuss in the next video. So thank you.